Alright, here though, look at this. Evaluate the limit as x goes to 0. So if I plug in 0, remember the first thing you do is direct substitution. If I plug in 0, I get 0 over 0 plus 0. That equals 0 over 0. That's an indeterminate form!
Yeah, I know. Frank, it's indeterminate.
So we gotta try some tricks. First trick. So the first trick is to factor everything. Evaluate the limit. Well, okay, so x in the top, I can't factor the top, but I can factor an x out of the bottom. That would leave me with x plus 1, right? Look at it. Now that cancels. So now we have 1 over x plus 1. So I'm taking the limit as x approaches 0 from both sides of 1 over x plus 1. So that's the first trick. This is actually a function that looks exactly like this, except for there's a hole in the function right at x equals -1. No, x equals 0. There's a hole at x equals 0. Anyway, so now what if we plug in 0? Now what happens? We get 1 over 1. So the limit of this function is actually 1. So that's the first trick. Factor everything, see if something cancels. If that doesn't work, you gotta try something else, man. On Khan Academy, it says whenever you see an indeterminate form, you should interpret it as that I gotta do more work. I had a teacher or a professor who used to say, indeterminate form. You know what that means? That means try again. So, yeah, we're gonna try tricks. Okay, on this one, evaluate the limit. Well, if we plug in -2, what do we get? We get 4, right? 4 minus 4, that's 0 in the top. And then in the bottom we get 4 plus a -6 plus 2. That's also 0. So indeterminate again. Let's see if we can factor stuff. I can factor the top. It's a difference of squares. That's x plus 2 times x menos 2. And in the bottom, I'm factoring this trinomial. That would be, what, 2 times 1? Divided by x. Okay, so that'd be x plus 2 and x plus 1. So that cancels. Sweet, hot dog. Plug in -2. Now try direct substitution. So if I plug in -2, what will that be? This will be -4 on top. -2 plus 1, that would be -1. That would give me +4. The answer here is +4. Are you sure?
I'm positive.
It's a joke. So that was kind of a redundant example. You're still factoring. Let's try another one. Okay. I mean, this one's still kind of the same idea, except for the difference is we're going towards an unknown value, and we have a sum of cubes there. So let's see how to factor a sum of cubes. This was a SOAP problem, same, opposite, always positive. This is just a formula you'd have to remember. Hopefully you've seen this before and now you're recognizing it. That's how we factor the top. If I were to plug in a, though, if I were to plug in a for x, what would I get? I would get -a cubed plus a cubed. That would be 0. So that would be 0 in the top. And then plug in -a plus a, that's also 0. So I have to do some tricks, right, because I get an indeterminate form, which means try again. So I'll factor the top. That's a sum of cubes, so the top factors into x plus a, right? Same sign as here. So I'm going to have the same sign, the opposite sign. So minus and then always positive. Here I have a squared. My a in this case is x, so I have x squared. My b is in this case is a. That's confusing. And then ax is a times b, or b times a. So there we go. That's factored now. And then in the bottom I have x plus a. Oh, look at that. Isn't that convenient? That looks like a 9. So that cancels out with that, and I'm left with this. So if I plug in negative a, I get, well, negative a squared is just a squared, minus negative a times negative a, so that changes to plus a squared, and then plus a squared. So that's 3a squared. That's my answer. The limit as x approaches negative a for that function is 3a squared. Okay, that's just factoring using a difference of cubes formula. Let's do something more complicated. So if I see this, evaluate the limit as h approaches 0 for this function. I first tried direct substitution. Plug in the 0 there. 2 plus 0 is 2. Squared is 4. 4 minus 4 is 0. So I get 0 over 0. I have to try some trick. First thing I'm thinking is maybe multiply this out. So this squared, that's just 2 plus h times 2 plus h. So what would that be? 4 plus, right? I'm just doing this. I'm going to do it in my head. 2 times h is 2h, so it'll be 4h, and then plus h squared, all divided by h, right? Is that right? Oh, wait, minus 4. Forgot about that. Minus 4. So that cancels out. Ooh, 4h plus h squared over h. And then you're thinking like, well, that didn't help. But remember, one of the first trick was to factor everything. So I'll factor out an h from the top, and I get 4 plus h over h, and the h's cancel. So we have 4 plus h. And now we can do direct substitution. So that equals 4 because h is going to 0. So this actually equals, well, I shouldn't write that. The limit as h approaches 0 of 2 plus h squared minus 4 all divided by h. That equals 4. Isn't that beautiful? Yeah, that's beautiful. That's beautiful.